Hi guys, this time we're going to talk about Venus. And before we begin our talk about Venus, we are going to talk about something called albedo. Now, albedo is a term that is used by astronomers and people who earth science people who are looking at reflectivity. And the actual definition of albedo is the fraction of the sunlight hitting a surface that is reflected back. If you have something that is bright white, for example, if you are out in the snow, you know you need to wear your sunglasses when you're out, even though it's very, very cold outside, you've got to wear your shades because of the fact that the bright white snow is very reflective and lots of light will come off of them. If you are someplace where the ground is very, very dark, for example, like a plowed field, there is less light that is reflected off of surfaces that are dark. So when scientists look at the percentage or amount of light that is reflected, they're referring to albedo. Now, why are we talking about this? Well, we're talking about this because of the fact that we're going to deal with Venus, and Venus has a very, very high albedo. Again, this is just some demonstrations. Grass, 5 to 25%, water, up to 80% of the sun can reflect, snow, 50 to 90%. So material changes, amount of reflected light will change. And it's one of the tools used by astronomers to determine what the surface of a planet or a moon, what's it made of, what does it look like. And if you look at the planets in our solar system and you look at the albedos, Mercury has an albedo of 0.12, meaning it's not terribly reflective. Venus, 0.59, so it's very reflective. It also means that it is going to be quite bright in the sky. Earth, 0.3, Mars, 0.15, Jupiter, 0.44. Jupiter's quite reflective. Again, Saturn, 0.46. Uranus and Neptune are both over 0.5. So you can see all of the gas giants have relatively high albedos, meaning that they're going to be quite reflective, and we can see them quite easily. Of the inner rocky terrestrial planets, only Venus has a really big albedo. Now, Venus is zero point 0.7 astronomical units from the sun. So, of course, it's closer than we are. There is no moon, and it's named for the goddess of love, Venus. So, Venus in Latin, I believe it's Aphrodite in Greek, and the goddess of love planet, Venus, is very similar in size to our Earth. It has been called our sister planet periodically because of its size and shape, not because of its atmosphere. Venus, of course, is close to the sun, and because of the fact that it's so close to the sun, we see it at sunrise and we see it at sunset. Those 2 points of observation are due to the fact that wherever the sun goes, Venus is going to be quite close. It's never going to be above 45 degrees above the horizon because of this distance. We talked about the fact that Venus has a very, very high albedo of 0.59, and I will never ask you exactly what the albedo of Venus is. It doesn't matter, just so you know it's quite high. But because of this high reflectivity, no other single object in the sky has been mistaken for a UFO more often than Venus. It's very, against a black sky, it's very difficult to judge speed and distance. And often when people see or think they see a UFO, it's our good friend Venus. It has a revolution around the sun of about 225 Earth days, so about 2/3 of one of our years for Venus to go around. It rotates on its own axis 243 days. So what does that mean? One day on Venus is longer than 1 year. It takes more time for Venus to rotate on its own axis than it does for it to orbit around the sun. Also, Venus orbits retrograde. Now, retrograde, if you remember, is backwards. So everything in the plane of the ecliptic goes in the same direction. Earth, Mars, everything rotates in the same direction. And Earth's rotation looking from the top would look like that. Mars's rotation looking from the top would look like that. Venus orbits around the sun in the same direction we do. The thing that's wacky is that if you start looking at how Venus orbits on its own axis, it orbits backwards to everything else. Well, how the heck did that happen? It's believed that when it was very, very young, a relatively large asteroid or some other astronomical body hit it and messed up its rotation. So Venus has kind of a weird year, day is longer than a year, and it rotates backwards. Composition of Venus, solid metal core, kind of like our own Earth. There's not a real magnetic field around it, meaning that we don't think that it has a nice iron core inside that is rotating to give it a magnetic field. Because of that, it can't protect a lot of life and protect itself from a lot of incoming solar wind. The other thing that's wacky about Venus is it only has one tectonic plate. On planet Earth, there are dozens of tectonic plates. On Venus, there is only one. It's very volcanic crust. Well, it is believed there are over 1,600 major volcanoes on Venus and over 100,000 total volcanoes on Venus. So it's crazy, nutty, volcanically active. All of those volcanoes have thrown into the air of Venus a lot of sulfur dioxide. Now, sulfur dioxide mixed with water makes sulfuric acid. And you are familiar with sulfuric acid. That is the acid that is in car batteries, battery acid. You would not want to take a vacation on Venus because it would literally be raining battery acid down on top of you. It's a very harsh and hostile environment. The atmospheric pressure on Venus is also nutty crazy big. It's about 90 times the pressure that is on Earth. The gases that make up the air are very, very heavy, made of very, very heavy gases, and there are lots of them. And so they push down about 9 times more than they do, 90 times more than they would on Earth. That means there's a high atmospheric pressure. So what does that mean? Well, let me give you a little example. Back in the 1960s, the Russians sent a probe to Venus called Venera. This Venera probe, big honkin' heavy metal probe, landed on the surface of Venus. It weighed over a ton, and within moments of it entering the atmosphere, or actually landing, it was crushed like a pop can under someone's feet. And that all occurred because of the atmosphere of Venus. Now, Venus is suffering from something that is called a runaway greenhouse effect. And we'll talk more about this greenhouse effect in a little bit. But the runaway greenhouse effect on Venus is due to the fact that there is this thick atmosphere made of lots of carbon dioxide and sulfuric acid and other things like that. And these things will hold heat in and not allow the heat to escape again. Best example I can give you is if you've ever gone camping. If you ever go camping and the night is clear and cold, if it's very, very clear, it's going to be cold. It's going to be a cold night. But if you pay attention, cloudy nights are warmer. That's because the heat comes in from the sun all day long and it can't escape, or very little of it can escape through the clouds. On a cold night, heat came in all day and heat goes out all night, and it means everything is just colder. Well, all of the gases in Venus holding in all of that heat means that it is really warm on Venus. And this creates this runaway greenhouse effect. Believed earlier in Venus's life, the temperatures and things were a lot more comfortable, but it has just this big, hot, gaseous environment. It doesn't allow heat to get back. And so the surface of Venus, 460 degrees Celsius, we're talking well over 800 degrees Fahrenheit. Yeah, you do not want a vacation on Venus. And we're going to keep going. All right, that's going to do for that one. And I will see you for Mars.